Now let's look at an example of putting this principle to work. Let's assume that we have two banks. Bank A is going to pay interest of 7% compounded every 39 days. A rather unusual compounding period, but hey, this is an example. Furthermore, it's an academic example. Bank B wants to have an equivalent rate. So what we need to solve for Bank B is what interest rate X are they going to post as a rate. Now the interesting thing about Bank B is they compound 7 times per year. So Bank A, 7% compounded every 39 days. Bank B compounds at some rate X percent, which we have to calculate, and they compound 7 times per year. Now, being an academic professor, and furthermore being married, and even furthermore having 2 teenage daughters, that means I have almost zero money to invest. But let's assume that I have $1. I actually have $1 that I can deposit in Bank A, and I have another $1 that I can deposit in Bank B. So in Bank A, if I deposit $1, at the end of the year, the amount of money I'm going to have is $1 multiplied by 1 plus 7% divided by the number of compounding periods per year, which is going to be 365 divided by 39, all raised to the power of 365 divided by 39. That is the amount of money that I will have from depositing one of my 2 loonies that I have in Bank A. In Bank B, what I will have at the end of the year is $1 multiplied by 1 plus my X percent, which I have to calculate, divided by 7, raised to the power of 7. If X percent compounded 7 times per year is to be equivalent to 7% compounded every 39 days, these two amounts here must be equal. So in essence, I'm going to set up this equation equals to this equation and solve for X percent. So setting the 2 equations equal, here's the amount that I will get after 1 year from depositing my $1 in Bank A, and here's the amount I will get after a 1 year deposit in Bank B. The first thing that you'll notice is the $1 cancel out. I could divide both sides by $1, that immediately goes. Now, according to Please Excuse My Dear Aunt Sally, if I want to isolate my X percent here, the first thing I must do is get rid of that exponent. So what I'm going to do is I'm going to basically raise both sides of the equation to the power of 1/7. What that's going to leave me with over here on the right hand side, something raised to the 7th power and then taking the 7th root of it, means that this essentially cancels out, and on the right hand side of the equation I'm going to be left with 1 plus my X percent divided by 7. On the left hand side of the equation I'm going to have 1 plus 0.07 divided by 365 divided by 39 all raised to the power of 365 over 39 multiplied by 1/7. The next step that I can do to help myself along is I can now subtract 1 from both sides. If I subtract 1 from both sides, obviously 1 minus 1 here cancels out, and I'm left with x% divided by 7 on the right-hand side of my equation. Okay, now we're almost home here. Over here on the right-hand side, we have x% divided by 7, so it's simply going to be a matter of getting rid of this 7 over here on the right-hand side will lead us to the final solution. And of course, we do that by multiplying both sides of the equation by 7. So we take all of this and we multiply by 7. The 1 over 7 multiplied by 7 cancels out, and we're left with our solution that x%, the x that we want to solve for, is equal to 1 plus 0.07 divided by 365 over 39, all raised to the power of 365 divided by 39 multiplied by 1/7 minus 1, and all of that multiplied by 7. When I work that out, I get that x is equal to 0.070088, or x is equal to 7.0088%.